Right now, as you watch this video, you're spinning through space at over 1,000 miles per hour. You can't feel it because everything around you is moving at exactly the same speed. But what if, in this exact moment, Earth just stopped? Everyone and everything not nailed down would instantly fly eastward at 1,000 miles per hour. Cars, buildings, people, entire cities would become projectiles launched horizontally across the planet's surface. You'd experience forces 25 times stronger than a fighter jet pulling 10 Gs. But the flying debris would be just the beginning. The oceans wouldn't stop with the Earth. 300-foot-tall tsunamis would race across every continent at the speed of a commercial airliner, carrying the debris of civilization along with them. New research published in 2024 has revealed exactly what would happen in the first 24 hours after Earth stopped spinning, and the physics involved are more terrifying and more fascinating than any disaster movie has ever imagined. Because the spinning stops, but the destruction is just getting started. To understand why stopping Earth's rotation would be so catastrophic, you need to grasp just how fast we're actually moving right now. At the equator, the surface of our planet is spinning at 1,040 miles per hour. That's faster than the speed of sound. If you're watching this from New York, you're moving at about 790 miles per hour. From London, about 650 miles per hour. Even if you're near the North Pole, you're still spinning at hundreds of miles per hour, and this has been happening for 4.5 billion years without stopping for even a fraction of a second. This is where Newton's first law of motion becomes absolutely critical. An object in motion stays in motion unless acted upon by an external force. Right now, you, your house, your car, and everything around you is in motion at these incredible speeds. Here's what makes this scenario so complex. Stopping Earth's rotation doesn't just affect the surface. The atmosphere, the oceans, even the molten core would all be affected differently because they're moving at different speeds and have different properties. It's like trying to stop a spinning top by grabbing just the outside edge. Research in atmospheric physics shows that sudden changes in planetary rotation would create atmospheric chaos unlike anything we've ever observed. Our atmosphere is essentially a fluid wrapped around a spinning sphere. The jet streams, trade winds, and weather patterns we see today all exist because of Earth's rotation. Earth's rotation is also what gives us our 24-hour day-night cycle. One complete rotation equals 1 day. But if the planet stopped spinning, one side would face the sun continuously while the other remained in permanent darkness. But here's what makes this scenario truly terrifying. The laws of physics don't care about our comfort or survival. They just operate. And when those laws meet the reality of a suddenly stopped planet, the results are beyond catastrophic. Let's walk through exactly what would happen in the first 5 minutes after Earth stops spinning. And I mean exactly, because physicists have actually calculated this scenario down to the second. Minute 1. Every car on every highway would instantly become a projectile moving at highway speeds plus Earth's rotational speed. A car driving east at 60 miles per hour would suddenly be moving at over 1,000 miles per hour relative to the ground. Every airplane in the sky would face impossible physics, trying to land on runways that are no longer where they're supposed to be. Minute 2. Buildings would begin collapsing. Not from earthquakes, but from the sudden change in forces they were designed for. Skyscrapers are engineered to handle wind loads and their own weight, but not sudden lateral forces from their contents flying eastward at supersonic speeds. Minute 3. The oceans would reveal their true power. Water has inertia, and the ocean contains 1.37 billion cubic kilometers of it. When Earth stops but the water doesn't, you get waves that make tsunamis look like ripples in a bathtub. Studies in fluid dynamics show that the ocean basins would essentially become launching ramps for incomprehensible amounts of water. We're talking about waves 300 to 500 feet high moving at 600 miles per hour. The kinetic energy involved would be equivalent to thousands of nuclear weapons being detonated simultaneously across every coastline. Minute 4. The atmosphere itself becomes a weapon. Wind speeds would instantly jump to over 1,000 miles per hour near the equator. But these aren't normal winds. They're atmospheric shear forces that would strip away everything from topsoil to entire forests. Minute 5. Any human still conscious would be experiencing G-forces that make astronaut training look gentle. Fighter pilots black out at 9 Gs. The sudden deceleration from Earth stopping would subject people to forces of 25 Gs or more. But the 5-minute mark is when the really catastrophic effects begin to cascade. What most people don't realize is that Earth's rotation doesn't just affect the surface. It affects the entire planet's shape and internal dynamics. And when rotation stops, the planet itself begins to change. Right now, Earth isn't actually a perfect sphere. The centrifugal force from rotation has created an equatorial bulge. Our planet is about 27 miles wider at the equator than it is from pole to pole. When the spinning stops, this bulge becomes a problem. The excess mass at the equator would begin redistributing toward the poles due to gravity. This sounds gradual, but on geological timescales, it would be catastrophically fast. We're talking about adjustments that normally take millions of years happening in months or years. Research in seismology shows that the tectonic implications would be staggering. Earth's crust would be under stress patterns it has never experienced in 4.5 billion years. We would see earthquakes of magnitudes we don't even have measurements for. The entire ring of fire around the Pacific would likely activate simultaneously. But here's where the physics gets truly fascinating and terrifying. Earth's magnetic field, which protects us from deadly solar radiation, is generated by the circulation of molten iron in our planet's core. This circulation is driven by rotation. Within weeks of Earth stopping its rotation, our magnetic field would begin to weaken dramatically. Within months, it could collapse entirely. This would leave Earth's surface exposed to the full force of solar wind and cosmic radiation. We know exactly what happens to planets without magnetic fields because we can see Mars. Mars lost its magnetic field billions of years ago, and the solar wind has been stripping away its atmosphere ever since. But the atmospheric effects start much sooner than magnetic field collapse. Assuming any part of civilization survived the initial catastrophe, survivors would inherit a world with physics unlike anything in human experience. Without rotation, one side of Earth would face the sun permanently, while the other remained in eternal darkness. The day side would reach temperatures over 200 degrees Fahrenheit as solar energy continuously heats the same surface area. Meanwhile, the night side would plunge to temperatures colder than Antarctica, potentially reaching negative 200 degrees Fahrenheit. But the atmosphere would still exist, at least initially, and it would try to redistribute this temperature difference. This would create the most extreme weather system ever seen on Earth. Continuous hurricane-force winds flowing from the hot side to the cold side. The only potentially habitable zone would be the twilight band, the narrow region between permanent day and permanent night where temperatures might be survivable. This would be a moving target as the weather system shifted, but it represents the only hope for long-term survival. Climate models show that the atmospheric dynamics would be unlike anything we've ever observed. You'd have massive convection cells carrying superheated air from the day side to the night side, where it would freeze and sink. The temperature differential would drive winds that make Category 5 hurricanes look like gentle breezes. The water cycle as we know it would cease to exist. On the day side, all surface water would eventually evaporate. On the night side, all atmospheric moisture would freeze out as ice and snow. The twilight zone would become the only region where liquid water could exist. From a biological standpoint, this would represent the most extreme evolutionary pressure Earth has ever experienced. The few organisms that could survive would face selection pressures that would drive evolution at unprecedented rates. But there's one more terrifying implication we haven't discussed yet. Earth's rotation is intimately connected to the Moon's orbit through tidal forces. The moon's gravity creates tides in our oceans, but Earth's rotation creates tidal forces on the moon. These forces have been gradually slowing Earth's rotation and pushing the moon away from us for 4.5 billion years. When Earth suddenly stops spinning, the conservation of angular momentum in the Earth-Moon system would be completely disrupted. The moon would no longer experience the tidal forces that keep it in its current orbit. Studies in orbital dynamics show that without Earth's rotational energy to maintain the tidal lock, the moon's orbit would become unstable. Over geological time, it could either spiral inward toward Earth or escape entirely into its own orbit around the Sun. Either scenario would have catastrophic implications for what's left of Earth's climate and tidal systems. But the implications extend beyond just the Earth-Moon system. Earth's rotation contributes to the overall stability of the inner solar system. Sudden changes in Earth's angular momentum could have subtle but measurable effects on the orbits of other planets over millions of years. The laws of physics make it clear that Earth cannot simply stop spinning without an external force. The rotational energy of our planet is so enormous that stopping it would require more energy than humans have ever produced in our entire history. The only scenarios that could stop Earth's rotation would involve cosmic catastrophes so massive that stopping the rotation would be the least of our problems. An asteroid impact large enough to stop Earth's spin would completely destroy the planet. So why do scientists study this impossible scenario? Because understanding extreme cases helps us understand the normal operations of our planet. These models help us appreciate the delicate balance of forces that make Earth habitable. Every sunrise you see is proof that Earth is still spinning at exactly the right speed to maintain the conditions that make life possible. What this thought experiment reveals is just how extraordinary our planet's current state actually is. Earth has been spinning at roughly the same speed for billions of years, maintaining the precise conditions needed for oceans, atmosphere, magnetic fields, and ultimately, life. We live on a planet where the rotation speed, magnetic field strength, atmospheric composition, and orbital distance from the Sun all fall within incredibly narrow ranges that allow complex life to exist. Change any one of these factors dramatically, and Earth becomes uninhabitable. So, the next time you wake up to a sunrise, remember that you're witnessing one of the most reliable phenomena in the universe, Earth completing another perfect rotation in its 4.5 billion year journey through space. What aspect of this scenario surprised you most? The immediate destruction, the long-term climate effects, or the orbital consequences? Let me know in the comments and subscribe for more explorations of the extreme physics that govern our universe. Because understanding the impossible helps us appreciate the incredible reality we actually live in.